All right, welcome back to Mathematics Lifeline. In today's video, I'm going to be doing 10 levels of limits, levels 1 through 10, that progressively get harder. Now, of course, these are subjective rankings, so level 1 to me is the easiest and level 10 to me is the hardest. However, of course, it's going to be different for everybody, but these are going to be 10 limits that I think progressively get harder. As always, feel free to try these and pause the video at the start of every level and let me know how many you get right. So let's go ahead and get started with level 1. So we have the limit as x goes to 0 of 3x plus 5. Now, 3x plus 5 is just a line, right? This is a linear function. So we could even graph this. So 3x plus 5, we'll say here is 5, and we have a slope of 3 going through that point. So we have this and this. That's a rough sketch of this line. And this is continuous everywhere, right? So we don't have to worry about any asymptotes or anything like that. Which the nice thing about that, it means we can just take the 0 and plug it right into the x. So this is going to be 3 times 0 plus 5, which of course this becomes 0, so 0 plus 5 is 5. And that is the end of level 1. The limit as x goes to 0 of 3x plus 5 is equal to 5. Now let's go ahead and move on to level 2. All right, so here we have level 2. So this one is the limit as x goes to 0 of x plus 2 all over x. Now, this one is a little tricky, and the reason is because you have to really know what it means to have a limit. Now, remember, you can take limits from the left and from the right. So we're going to actually look at two cases here. We're going to look at the limit as x goes to 0 from the left side of x plus 2 over x. And then we're going to look at the limit as x goes to 0 from the positive direction of x plus 2 over x. And the reason we're doing this is because for this limit to exist, these two have to equal the same thing, right? The limits coming from the left and from the right have to be equal. Now let's just think about this for a second. We don't even need to think about the actual number here. But we know that if we're approaching 0 from the left, that means we're still in the negative numbers. So we can always plug in, for example, a negative 0.00001, right? This is getting closer to 0, but it's not at 0 because we're not worried about the function value there. So this is going to give us some negative number, right? So I don't know what that number is, but it is a negative number. Now with this one, we're approaching 0 from the positive direction. So the same thing, but what if we choose x to be 0.00001? We're allowed to do that. That's a number that's getting closer to 0. But when we plug this in, right, this number up here is a positive number. And this number down here is also positive, which means this one is going to give us a positive number. And since that happens, because we're getting a negative number here and a positive number here, this whole limit does not exist because from the left and from the right, the answers are not the same. So that's going to be our answer for level 2. We'll go ahead and move on to level 3. All right, so here we have level 3. This one is the limit as x goes to 3 of x squared minus 9 over x minus 3. Now, for this video, I do want to point out that we're not going to use L'Hopital's rule for any of these questions. Now, this one, I agree, it would be very easy to use here, but we're not going to do that because personally, I think it's more fun to go through the whole factoring step and solve this limit I can't say the proper way, but the more traditional way and the way you first learn how to do it. So we're not going to use L'Hopital's rule here. The way we're going to do this is, like I hinted at just now, we need to factor this. So if we look at the numerator, we have x squared minus 9. Now this is actually a difference of squares. So when we factor this, remember that the rule for difference of squares is a squared minus b squared can factor to a plus b times a minus b. So when we do that for the numerator, we're going to end up factoring that. So we still have the limit as x goes to 3. But the numerator will now factor to x plus 3 times x minus 3. Right? Because our b here is actually 3 because 3 squared is 9. Right? So this is the form we have. This is what we turned it into. And the bottom we're not going to change. We're going to keep it at x minus 3. Now, you could probably see what we're going to do. The nice thing about pulling this factor, or factoring this, is that now we can cancel out this x minus 3 with this x minus 3. So then we're just left with the limit as x goes to 3 of x plus 3. And again, Just like the first one, this is a linear function, so we can just plug this right in, and we'll get 3 plus 3, and of course that is equal to 6. And that will be our answer for level 3. So let's go ahead and move on to level 4. All right, so here we have level 4. This one is the limit as x goes to 3 of x minus 3 over 1 over x minus 1 over 3. Now what we want to look at here is we have this 3. If we plug it in, so that for this x down here, we'll have 1 over 3 minus 1 over 3, which is 0, and we're dividing by 0. So obviously we're going to need to work with this a little bit. Now here's what we can do. We're actually going to combine these fractions. And the reason we're going to do that is because we should be able to cancel something if we do. So we're going to combine these fractions right here. So when we do that, we're going to have the limit as x goes to 3, still x minus 3 on top. But we want to subtract these fractions. So if we're going to subtract 1 over x minus 1 over 3, obviously this one right here needs a factor of 3 in the denominator, so we're going to multiply by 3 over 3. And this one over here needs this factor of x, so we're going to multiply by x over x. Now when we do that, we're going to get 3 over 3x minus x over 3x. So what we'll have is 3 minus x over 3x. Okay, so now this is what our bottom has turned into. So we're going to have 3 minus x over 3x. So now what we're going to want to do is we're dividing by a fraction. So when we divide by a fraction, we know we can flip and multiply this fraction. So this is actually the same thing as the limit as x goes to 3 of, we'll have 3x times x minus 3 over 3 minus x. All I did was flip this fraction and multiply it with the x minus 3, and that's what we're getting. So if you notice what we have here, we still have this issue where if we plug in 3, we're going to end up having 0 in the denominator. So you might be thinking you did something wrong, but we can actually manipulate this a little bit. Here's what we're going to do. We're going to multiply the top and the bottom here by a -1. So we'll multiply by -1 over -1. And the reason that we do that is let's look at -3 minus x. This is what we're doing to the denominator. When we distribute this negative, we're going to get a -3 plus x, which is the same thing as x minus 3. So now when we rewrite this limit, we're going to have the limit as x goes to 3. This will just be a minus 3x times x minus 3 over, when we multiplied the -1 by the 3 minus x, we got x minus 3. And this is great because now we can cancel out this with this. And we'll just have the limit as x goes to 3 of minus 3x. And again, this is just a line. So we'll plug in this 3 right here. We'll get minus 3 times 3, which is minus 9. And that will be our answer for level 4. So let's go ahead and move on to level 5. All right, so here we have the limit as x goes to 9 of square root x minus 3 over x minus 9. Now, the trick for this one, we'll get there in just a second, but the first thing we need to do is we want to plug in 9 to see what we get, right? So when we plug in 9 up here, we're going to end up getting the square root of 9 minus 3, which is 3 minus 3, that's 0. And if we plug in 9 down here, we're going to get 9 minus 9, which is 0. So we have 0 over 0, indeterminate. So we need to do a little bit of work with this. So what we're going to do is we're going to use difference of squares again. Now, it's not as clear for this one, I agree. Now remember the difference of squares rule is a squared minus b squared can factor to a plus b times a minus b. That is the rule. Now, it's not clear, but here's what we're going to do. This denominator right here is going to be a difference of squares. So we're still going to have the limit as x goes to 9. The square root of x minus 3 will stay in the top. But the bottom, we're going to factor using this. So if a squared is x, that means that a is going to be root x. So we know we're going to have root x plus something times root x minus something. That's going to be the factored form. Now, of course, b squared here is 9, which means that b is going to be 3. So we'll have root x plus 3 or times root x minus 3. And this is great because, again, we can cancel out the root x minus 3 with the root x minus 3. So then we just have the limit as x goes to 9 of 1 over square root x plus 3. And when we plug in 9 to this, we'll get 1 over square root 9 plus 3. This is 3 plus 3, so we're going to get 1 over 6. And that will be our answer to level 5. This one, if you see this immediately, is not that hard of a limit, but a lot of people will miss this being a difference of squares because it just doesn't look like one. So that's why this one is in level 5. But let's go ahead and move on to level 6. All right, so here we have level 6. This one is the limit as x goes to 2 of x cubed minus 2x squared plus 3x minus 6 all over x squared minus 4. So the way we're going to do this one, this is just a lot of factoring here. So this is going to be the same as the limit as x goes to 2. And we're going to try to factor what we can. Now, the easiest one to factor is the denominator because you could probably see it immediately. This is difference of squares. So using that same rule, it's going to factor to x plus 2 times x minus 2. So that is what the bottom factors to. Now let's look at the top. So we're going to actually factor by grouping. So if we have x cubed minus 2x squared plus 3x minus 6, we're going to take this one, and we're going to factor what we can out of it. So when we look at this first term right here, we want to look at what we can factor. Now, the constants don't share anything other than a 1, but that's pointless to take out. But what they do share is an x squared. So we could take an x squared out of this first one, and we'll have x minus 2. Now with the second one, we can take out a 3. So we'll take out a 3, and what do we have left over? Well, the 3 goes away from this, it'll be an x. This one divided by 3 is a minus 2. So then we can actually factor this again. We're going to take out an x minus 2 from both of these terms. So we'll have an x minus 2 times the other factor is going to be what's left over. So it's going to be x squared plus the 3 that we took out. So this right here is the factored version of the numerator. So we're going to take this and put it back in over here. So x minus 2 times this is x squared plus 3. And again, you can see it. The x minus 2 cancels. So then we'll have the limit as x goes to 2 of x squared plus 3 over x plus 2. And this one has no issues with dividing by 0. So let's go ahead and plug in 2. So we'll have 2 squared, which is 4, plus 3 over 2 plus 2. So of course that is 7 over 4. And that will be our answer for level 6. So let's go ahead and move on to level 7. All right, so this one is level 7. So this is our first limit as x goes to infinity, and this one is of x cubed plus 8x minus 4 over 2x cubed plus 3. Now, with these limits as x goes to infinity, if we were to plug in x here, you see that we would get infinity over infinity, and we can't really say what that is just by using that. So what we need to do is we are going to divide every term by the highest degree term in these polynomials. So as you can see in both of these in the numerator, what is the highest degree there? Remember, the highest degree is the highest exponent of x. So this one is going to be x cubed is the highest degree. So that degree is of 3. This one is the same thing because this x cubed is all that matters. So the degree of that is 3. So we need to divide every term in here by an x cubed. So this is the same thing as the limit as x goes to infinity of x cubed over x cubed plus 8x over x cubed minus 4 over x cubed all over 2x cubed over x cubed plus 3 over x cubed. So now we want to do a lot of simplifying here. So we have the limit as x goes to infinity. X cubed over x cubed is going to be a 1. 8x over x cubed is going to be an 8 over x squared. The 4 over x cubed will stay the same, so minus 4 over x cubed. Over this, the x cubes will cancel, so we'll get a 2. Plus, the 3 over x cubed will also stay the same. Now this is very, very helpful because remember, when we plug in infinity and x is in the bottom, as long as there's no x in the numerator, we can say that this goes to 0, this goes to 0, and this goes to 0. So this is really just 1 over 2 because everything else went to 0. So of course, it's just going to be the constants that are left over, so it's going to be 1/2. And that is our answer for level 7. So this is the degree rule here. Now there's another way you can do it just by looking at the degree and you can immediately tell what it is, but most of the time professors or your instructor will want this way because this is the more formal, systematic way to do it. So let's go ahead and move on to level 8. All right, so here's level 8. This one is the limit as x goes to 0 of x over root x plus 4 minus 2. Now when we plug in x equals 0, the denominator, we're going to have square root of 4 minus 2, which of course is going to be 0. So we need to work with this a little bit. Now, this question, if you don't know what to do immediately, you will be stuck on this for a long time. And the reason is because we need to know to multiply by the conjugate. So what we're going to do is let's look at multiplying by the conjugate outside of the limit. So we have x over square root of x plus 4 minus 2. Now the conjugate says we multiply by this denominator, but instead of a minus 2, it's a plus 2, and we're going to do it in the numerator and denominator. So we're multiplying by root x plus 4 plus 2 over root x plus 4 plus 2. This is the conjugate right here. So we're going to actually need to multiply these together, and we'll be able to rewrite this limit. So in the numerator, there's not a ton we can do, right? We're just going to have x root x plus 4 plus 2x, right? We're just distributing x to those terms. Now the bottom, if you remember, this is actually the factored version of a difference of squares, right? Or we can just FOIL them and multiply it directly, but if we know that, we can do this much quicker. So what it'll be is this term squared, right, minus this term squared. So square root of x plus 4 squared, the square root and the square will cancel out, so we'll get x plus 4. And then we're going to have minus this other part squared. So it's actually going to be a minus 4. So now we can see that these will actually cancel out. This plus 4 and this minus 4 will cancel. So we'll end up with x root x plus 4 plus 2x all over x. So one more time, what we're going to need to do is manipulate this a little bit more. So what we're going to do is we're going to take an x out of the numerator. So we're going to have x times square root of x plus 4 plus 2 over x. And you'll see the x's can cancel out now. So this is the same thing as the limit as x goes to 0 of square root x plus 4 plus 2. And of course, when x goes to 0 here, we're going to have square root of 4 plus 2, which of course is equal to 4, since the square root of 4 is 2. So that's the end of level 8. Let's go ahead and move on to level 9. All right, so here's level 9. So we're going to take the limit as x goes to 0 of x plus 1 to the 7 over x. Now, when we plug in 0 to this, we're going to end up getting 1 to the infinity. And 1 to the infinity is an indeterminate form. So in some way or another, we're going to need to manipulate this. So here's what we're going to do. We want to try to pull this 7 over x down. So we're going to say that y is equal to x plus 1 to the 7 over x power. Now, how can we get that 7 over x down? Well, the easiest way is going to take the natural log of both sides. So we're going to take ln y is equal to ln of x plus 1 to the 7 over x. Now remember that when we have this natural log and we have something to a power, we can pull the power down in front. So this is equal to 7 over x ln of x plus 1. And again, we can rewrite this as ln y is equal to 7 ln of x plus 1 over x. So what we're going to do is we're going to say ln y is equal to the limit as x goes to 0 of 7 ln of x plus 1 all over x. Now, In this case, when we plug in 0 here, we're going to get ln of 0 plus 1, which is 1, and that is going to be, ln of 1 is always 0, remember? So this numerator is 0, and of course when we plug in 0 down here, we're going to get 0 as well. So if we get 0 over 0, we're actually going to use L'Hopital's rule here because it's going to be way easier. So we're going to use, so we get 0 over 0. So we're going to use L'Hopital's rule. L'Hopital's rule. I'm just going to write it like that. So we're going to take the derivative of the top and the bottom. So this is going to be equal to the limit as x goes to 0. So 7 ln of x plus 1. So if we're going to take the derivative of this, we have 7 ln of x plus 1. Remember, the 7 goes along for the ride. Now remember, ln is always going to be 1 over the input, so it's going to be 7 over x plus 1 times the derivative of the inside, and the derivative of the inside here is just 1, so it doesn't matter. So this is our derivative for the top. So it's going to be 7 over x plus 1 all over the derivative of x, which is 1. So this is going to be equal to the limit as x goes to 0 of 7 over x plus 1. And now when we plug in x equals 0, we're just going to get 7. Now you have to be really careful because remember, that was ln y. So if we want to solve for y, which is going to be our limit in this case, we have ln y is equal to 7. So to get rid of that ln, we need to exponentiate both sides. So remember, when we exponentiate, this will cancel, and we'll get y is equal to e to the 7th. And e to the 7th will be our answer for level 9. So let's go ahead and move on to the final level, level 10. Okay, so here we have level 10. This one is the limit as x goes to infinity of square root x squared minus 9 over 2x minus 6. Now remember, when we have limits as x goes to infinity, we're going to try to use a form of degree rule. And the reason I have this as level 10 is because this tricks so many students. And the reason is because we need to divide every term by the highest degree. So in the bottom, it's clear that the highest degree is 1. But in the top, we have x squared. So you might think, okay, we need to divide by x squared. But the problem is we only need to divide by x. And the reason is because the square root of x squared has degree 1. So if we're dividing, this is really a degree 1 in here, just because it's under the square root, it's kind of hidden. So the way we're going to do this is we need to divide everything, like I said, by an x, because that is the highest degree. So in the bottom, it's pretty clear, right? We're going to have 2x over x minus 6 over x. Now in the top, if we want to divide the square root of x squared minus 9 over x, what we're able to do is we're able to square this x and pull it inside. So this is the same thing as the square root of x squared over x squared minus 9 over x squared. This is the same thing. And that's why it looks confusing, because you're dividing by x down here, and it seems like you're dividing by x squared in here, but you're really not. You're only actually dividing by x, because when you take the square root of x squared, it's going to give you x. So the numerator, we're going to have the square root of x squared over x squared minus 9 over x squared. And now, this isn't that hard of a limit, because this is the same process as what we did earlier. Right? Because remember, we're going to try to simplify everything. So the limit as x goes to infinity of the square root of x squared over x squared is just the square root of 1, because these will cancel, minus the 9 over x squared isn't going to go anywhere, all over. The x's will cancel here, so we'll have 2, minus, and the 6 over x will stay the same. And just like last time, when we plug in infinity into here, this is going to go to 0, this is going to go to 0, so this is really just equal to the square root of 1 minus 0 over 2 minus 0, which is the square root of 1 over 2, which is 1/2. And that will be the answer for level 10. So I hope you enjoyed this video. I hope it gave you some sort of challenge. Again, I know some of these are probably a little out of order, but I think it's fun to just do 10 somewhat increasingly hard limits. Especially going back to fundamentals. I mean, we only use L'Hopital on level 9, and the reason is just because it's so much easier to do it that way. But on the other ones, we didn't use it at all. So hopefully this provides you a little bit of challenge. Again, let me know how many you got right. I'm interested to see how everyone does. But if you don't have any questions, then I will see you in the next video. Thanks for watching.